The cigarette smoker's problem was first presented by Suas. There are three smokers and one agent. A cigarette is made up of ingredients tobacco, paper, and matchbox. Each smoker has infinite supply of one ingredient and the agent has supply of all ingredients. The agent repeatedly chooses two ingredients at random and puts them on the table, and the smoker who has the complementary ingredient can take two ingredients and make a cigarette and smoke. In this problem, the agent represents the operating system and the smoker represents the processes. The operating system should allocate the required resources to the process and at the same time avoid deadlock. And now comes the real-time scenario of this problem.
We have cigarette smoker problem with he's the agent with unlimited supply of three ingredients: tobacco, paper, and matchbox. He is the tobacco smoker. He's the smoker with unlimited supply of matchbox, and he's the smoker with unlimited supply of paper.
The deadlock situation. Imagine the agent puts out the tobacco and paper. Since the smoker with matches is waiting for tobacco, it might not be locked. And the smoker with tobacco is waiting for paper, so it is possible that it may also not be locked. Then the first thread will block on paper and the second will block on the match. That's a deadlock. Now here comes the deadlock situation.
Randomly keeping two items on the table. I'm taking the paper. I'm taking the matchbox. Shit, man! I have only paper and matchbox. I can't smoke. Man, I have the tobacco. I have the lighter. How I wish I had the smoke paper.
Now the Patil's version of this problem. There are two restrictions on the solution. The agent's code cannot be modified and conditional statements and array of semaphores are not allowed. With these restrictions, this problem is unsolvable and the Patil's version is also called as impossible version. However, while the first restriction makes sense, because the operating system's code should not be modified every time we need to solve a problem, the second restriction is not reasonable. According to David Parnas, he called such restriction artificial and said artificial restrictions makes many problems unsolvable. Smoker's problem hint. The solution proposed by Parnas uses three helper threads called pushers that respond to the signal from the agent and keep tracks of the available ingredients and signal the appropriate smoker. These are the variables used in this solution. The Boolean variables indicate whether or not an ingredient is on the table. The pushers use tobacco sem to signal the smoker with tobacco and the other semaphores likewise. Then this pusher wakes up anytime there is a tobacco on the table. If it finds is paper true, it knows that the pusher B has already run, so it can signal the smoker with matches. Similarly, if it finds match on the table, it can signal the smoker with paper. But if pusher A runs first, then it will find both is paper and is match false. So it cannot signal any of the smokers, so it sets is tobacco true. The other pushers are similar. Since the pushers do all real work, the smoker code is trivial. Now this is the code for pusher A. And this is the code for the smoker. Now here comes the visual demonstration of the solution.
Now I'm keeping matchbox on the table. You already have a matchbox, so you are out. Now I'm keeping paper on the table. You already have the paper. Yeah, man! Now I have the smoking paper and the lighter and tobacco also. Now I can smoke.